discrete distribution. That's right. Discrete distribution is the first type that I will talk to you. And on Friday, I will talk to you on continuous distribution. That's right. The continuous distribution, the common is the normal distribution. Okay, for today, I will talk to you in the discrete distribution first. Right, before we talk about the distribution that represents the probability distribution of a random variable. The commonly when you do the experiment, when you check the specification of your product, we only sample the data, sample your product from the population. That's right. As I talked to you in the last on Friday. That's right. On Friday, we talk about the random variable. Why we talk about the random variable? If you would like to control your product in the spec of the customer, in the spec of engineer, that's right. In industry, we produce many products. It's maybe 1,000, 1 million piece of product. If you would like to check your product, if in spec or not, it's possible to do only a small sample. That's right, 1,000 piece or 100 piece of 100,000 from 1 million. You cannot do all of your product. You only sample, but your sample is random. That's right. The random. Okay, we can call it the random variable. Okay, your variable is maybe discrete variable or continuous variable. Right. Also for this, we will talk about the discrete variable and also represent the discrete distribution. That's right, the discrete distribution. Okay, for this kit, we will show you the definition of the discrete random variable in terms of probability math function. That's right, math function. We have three definitions. The first definition, function of xi greater than or equal to 0. That's right. The probability should be greater than or equal to 0. And summation of fxi, function of xi should be equal to 1. And the last one, that means fxi equal to probability of x equal to xi. X is the random variable. Xi is the specified variable that you would like to calculate. Okay, conclusion from this is fxi is the probability. That's right, is the probability. And fxi or probability should be greater than 0 or equal to 0. That's right, not less than 0. And the summary of or value of the fxi should be equal to 1. That's right. The probability total should be equal to 1. This is the definition. Like for example, for this case, we have the sample space of random experiment. We have A, B, C, D, E, F, and the outcome is equal like the random variable. For example, we have outcome A, B, C, D, E, F, G, the variable that you random sampling from your population is maybe A equal to 0, B equal to 0. What means no A, no B? Yes, right. C equal to 1.5, D equal to 1.5, E equal to 2, F equal to 3. And then if you calculate of F xi, that's right. This is equal to probability at x equal to xi. That's right. Okay, for f xi. Okay, if we calculate f at xi equal to 0, f at x equal to 0, it should be right. We have 0 equal to 1, 2. We have 2, 0. That's right. 2 divided by total 1, 2, 3, 4, 5, 6. We have 6 numbers. That's right, equal to 1 over 3. This is function. That's right. This is the definition is probability math function. Probability math function of x equal to 0 equal to 1 over 3 or 2 over 6. Because we have 2 effects from 6. That's right. We have 2, 0 from 6 value. Okay, this is the probability. That's right. Equal to probability at x equal to 0. This is the meaning of this. Also the same for f xi equal to 1.5 for equal to probability at x equal to 1.5. 1.5 we have 1 2 value of 1.5. That's nice. Also 2 divided by 6. Total event is 6. But this value only 2 event equal to 1/3. That's nice. How about 2? We have 1 event. 3 we have 1 event. That means F2 equal to 1/6. F3 equal to 1/6. This is the probability math function. That's right. But equal to F at xi equal to some value. Okay, this for some example. And previously the definition of probability math function. And for this case, we talk about the cumulative distribution function. That's right. Cumulative distribution function equal to summary of fxi. That's right. Summary of fxi. That means the probability that x less than or equal to x. This is the meaning of this. That's right. Previously we talk about the letter. That's right. Small capital F. That's right. Fxi. This is the probability at xi equal to x equal to xi. If we talk about the summary of fi, it should be probability x less than or equal to xi. That's right. And also we have 3 definitions. Fx equal to probability at x less than or equal to xi equal to summation of fxi. The value is between 0 and 1. That's right. The value is between 0 and 1. And if x less than or equal to y, then fx less than or equal to fy also. This is the 3 definition of the cumulative distribution function. That's right. Okay, this for some example that we talk to you the cumulative distribution function. Okay, we assume that a day for production of 850 manufactured parts contain 50 parts do not conform to customer requirement. What does it mean? Okay, we produce 850 parts of the product. But in this 850, we have 50 parts that do not meet the customer requirement. But we did the fail. That's right. We have 50 fail. The good is 850 is fail. Fail for this case do not meet the customer requirement ก็คือไม่เป็นตามสเปคของลูกค้านั่นเอง Okay, we produce in a day is 850 parts. 50 parts is fail. Okay, we select 2 parts from the random. That's right. We select 2 parts from 850 without replacement. That's right. Without replacement. ก็คือเก็บมาแล้วไม่ได้อาศัยเขาเก็บนั่นเอง That's right. Without replacement from this batch. Okay, if we represent x equal to number of non-conforming parts or number of fail in the sample. That's right. What is the cumulative distribution function of x? We have possible 3 cases. X equal to 0, x equal to 1, x equal to 2. We have 3 possible cases. We sampling 2 pieces or 2 parts from 850. Equal to 0 means no fail. That's right. You collect only 2, but 2 of this no fail. That's right. ก็คือไม่ได้เจอตัวที่ผิดพลาดนั่นเอง Okay, it's x equal to 1. You collect 2. 1 is fail. 1 is good. That's right. X equal to 2. That means 2 of this part is fail. Okay. Okay. The first we calculate probability that x equal to 0. X equal to 0. Okay. The first one x equal to 0. We have 2 events. We have 2. The first event 800 divided by 850. What does it mean? Because 0 means no fail. That's right. We have 800 is good and 50 is fail. That's right. 50 is fail. But for 0, know this only from 800. That's right. Okay, for the first time, it's possible 800. Possibility is 800 because equal to 0. The 0 it means good part. That's right. The good part we have 800. For this case, the possibility is 800 divided by total. Okay, but the second time you collect again, it's only 0 fail. That's right. But the first time, that's right, you get only 1. Right? But now the total is 709. That's right, 99. And total is 849. The second one is 799 divided by 849. That's right. This for second one. You collect the first time, the possibility is 800 divided by total. But the second time, now you limit is 799 divided by total. That's right. The total is -1. That's right. The possibility is also -1. This is the probability or the possibility that you sample the collect the sample from population or from the 850. 2 piece is no fail. That's right. 2 piece is no fail. Okay. For the second one, x equal to 1. What does it mean? X equal to 1. 2 piece. That's right. 2 parts. 1 is fail. 1 is good. That's right. 1 is fail. 1 is good. Okay. For this case, we have to possible. You have to multiply 2 first. We have 2 events. That's right. 2 events. Because if you collect 1, if you collect 1 is good. Okay. 1 is good. It's 800 divided 850. And you collect another 1. It fail from 50. But total is 889. That's right. And for this case, it's possible to that you multiply by 2. Okay, for the last one, x equal to 2. 2 of part is fail. That's right. 2 of part is fail. The total fail is 50. That's right. Okay, the first collect 50 divided by total. And the second collect the 50, you collect 1 without replacement. Now only 49. That's right. 49. Okay, the second one is 49 divided by total. Total also is 849. That's right. Okay, this is the probability based on cumulative. That's right, the cumulative function, cumulative distribution function. Okay, in conclusion, probability at x equal to 0 or less than 0 equal to 0.886 or about 88.6%. That's right, 88.6%. And probability at x less than 1 or equal to 1. For this case, equal to this positive. We call it cumulative. That's right. This is the cumulative. Probability at x less than 1 equal to probability x equal to 0 plus x equal to 1. That's right. We have 2 events. This positive. Okay. And the last one, probability at x less than or equal to 2. That's right. Or equal to 2. Px less than or equal to 2 equal to Px equal to 0 plus Px equal to 1 plus Px equal to 2. That's right. This is the cumulative distribution function, for example. But total is 1 or 100%. Probability is 100%. And also we can plot for this. Okay, for the next, right? The mean and variance discrete variable. You can calculate the mean. You can calculate the variance of this distribution. The mean is the expected value of x. The mean should be calculated by summation x fx. And variance should be expected value of x minus mu squared. Right. Should be this formula when you calculate it. Now for this example, you can calculate the mean. That's why you can substitute our value by this. Summation x f x. That's right. Summation f x. This is x value. This is fx. Now this is fx. The mean value is summation x fx. That's right. 10 multiplied 0.08. This modified this. You summarize of this term. You get the average value. You get the average value. And also the next one, calculate this term, variance. Variance is summation x square fx minus mu square. That's right, minus mu square, like this, minus mu square. And then you can calculate the value, like this value. Right, 10 square multiplied 0.08 plus 11 square multiplied 0.1 plus until 15 square multiplied 0.07 and minus mu square. Right, you get value. Okay, for the next, I talk about the distribution. You have uniform distribution. You have the binomial distribution. That's right. For the first kind of distribution that I talked to you is uniform. Uniform means the same value. That's right. In the same value. For example, if you produce the sugar crystal or sugar solid, we would like to the all sugar crystal should be the same size. That's right. If you can produce the same size of sugar, you can consider the uniform distribution of crystal size. That's right. This is the constant sign, for example. Okay, for this case, the uniform mass distribution or mass distribution is defined by f xi equal to 1 over n, and the total number of samples. That's right, total number of samples. Because this is the uniform, that's right, uniform. It should be the value between A and B. That you can calculate the mean. This is the uniform function is 1 over n. And the mean of this uniform function is b plus a divided by 2. And variance you can calculate from this. So this is the basic symbol of the distribution. That's right, basic symbol of the distribution. Like for example, from the previous example, that's right, we have the number of the denote, number of the void. We have 48 void line. We call the line. That's right, we have 48 void. The number is between 0 and 48. That's right, this is maybe the minimum is A equal to 0, B equal to 48, 24. And then you can calculate the average. Average is A plus B divided by 2. That's right. Divided by 2, we get 24. And then you can calculate the variance. Oh, sorry, we have like this. It's average. This is the value. So you get 14.4. Okay, for the uniform, if you know A, you know B value, that's right, you can calculate mean, you can calculate the value. For this case, you have to know the variable x at minimum value, x at maximum value. That's right. The y value is the same because the uniform distribution. Uniform distribution. For the next, we call this binomial as binomial distribution. Binomial distribution, that means we have two possible events, two possible outcomes. That's right. Two possible outcomes. For this case, we call the Bernoulli trial. Each outcome, each event is independently, not depend each other. This is the binomial distribution. Right. Okay, before we talk about the binomial distribution, I will recall about the definition of factorial, because most of the next distribution we talk about the factorial. Right. And I talk to you only on Friday. That's right, on Friday. The definition of binomial, right? N factorial, sorry, n factorial equal to n multiplied n minus 1 multiplied n minus 2 until multiply n minus n minus 1. Like this. For example, is 3 factorial equal to 3 multiplied 2 multiplied 1. 5 factorial, 5 multiplied 4 multiplied 3 multiplied 2 multiplied 1. And also we have the spatial definition. It's 0 factor equal to 1. That's right. Equal to 1 factor for that case. Okay, and then you can find the definition of this notation, nx. That's right. Nx equal to n factorial divided by x factorial multiplied n minus x factorial. Like for example, 5 factorial. This should be 5 factorial. divided by 2 factorial multiply 5 minus 2 factorial. That's right. Equal to 5 factorial divided by 2 factorial. 5 minus 2 equal to 3 factorial. That's right. And this is equal to 5 multiply 4 multiply 3 multiply 2 multiply 1 divided by 2 multiply 1 3 multiply 2 multiply 1. That's right. Total you get 10. And this is the definition of factorial and definition of this notation. We can use this a lot for the discrete distribution. Okay, we come back to the binomial distribution. We have 3 definitions. For this case, it trial are independent. We have 2 events. The event is independent. That's right, independent. These 2 outcome or 2 event is success and fail. That's right. Good and not good. Success and fail. The probability of success is denoted as P. That's right. P is the probability of the success. Okay, for that case, the definition of binomial distribution, we can represent by this formula. That's right. Most the distribution is in formula. It's easy to fit your data to the equation of the binomial equation of normal, something like this. For this case, the formula that you calculate the distribution. This is the definition of factorial. That's right. P power x 1 minus P power n minus x. N is number of the sample. That's right. Number of your data. X is variable that you would like to calculate the probability. That's right. For some time you can represent by binomial x np. X is the variable that you would like to calculate. N is the total number of samples. P is the probability of success. That's right. Probability of success. Okay, sometimes you can use the binomial distribution in term binomial expansion. That's right. For constant a and b of binomial expansion. That's right. A b power n equal to summary of this term. As for this case, this is only one. That's right. Only one. But if the binomial expansion, you can a plus b power n and then the summation of previous term. Right. For this case, a equal to p of success, b equal to 1 minus p. This means the fail. That's right. P is the success probability. 1 minus p is the failure or unsuccess probability. But total it should be 1. That's right. Total it should be 1. This show you the curve for the binomial distribution. That's a binomial distribution. This is the variable. This is the probability of distribution for that case at n and p. For this case, at any n and p sometimes. Right? And also you can calculate the mean and variance of your distribution. The mean of the binomial, you can calculate n multiply p. That's right. Number of sample multiply probability of success. And this is the value. You can calculate by this. Okay, if we give you some example of the binomial distribution, that's right. For this case, we sample the water. That's right. The water has 10% of containing the organic pollutant. If you check your water, that's right, in water for use, that's right, the chance, the probability or the percent that will be contain the organic pollution. Organic pollution means the waste, that's right, or toxic compound in your water is 10% chance containing the pollution. Okay, if we assume that the sample are independent, that's right, independent for example. Okay, the first one determine the probability that in next 18 sample, but only 2 exactly pollution. That's right. Only 2 sample is actually pollution. And the second one determine the probability that at least 4 sample contain pollution. At least 4. That's right. 4. Greater than or equal to 4. And the last one determine the probability that between 3 and 7. That's right. We talk about the probability at x greater than or equal to 4 probability at x greater than 3 less than 7, something like this. This is x equal to 2. We have 3 event or 3 probability. Okay, the first one. Right, the first one, if we calculate x equal to 2, that means you calculate probability at x equal to 2. For this case, x means the sample that contain the pollutant. Right. Contain the pollutant. For this case, this is the formula for binomial distribution. That's right. The number of the sample is 18. That's right. Number of x equal to 2. We have 2 samples. That's right. 2 samples that we talk. Okay. P, this probability that will contain the pollutant is 10%. P equal to 0.1. 10%. But probability is 0 to 1 only. That's right. You have to divide the percent by 100. You get P equal to 0.1. Okay. P equal to 0.1, x equal to 2, n equal to 18. Okay, we get this. We substitute n equal to 18, x equal to 2, p equal to 0.1. To this equation, we get this. That's right, we get this. And also you use the definition of this, you get this term. And then you know the probability at x equal to 2. True sample will contain the organic pollutant is 0.284, about 28.4%. Probability that x equal to 2. Right. Okay, for the second question, at least 4. At least 4. X greater than 4. Right, for that case. Okay, from the definition, that's right, probability that x greater than 4 will be summation x equal to 4 until 18. That's right, until 18. 18x, p power x, 1 minus p power n minus x. That's right, from this formula. From this formula. But from the definition for this case, probability that x greater than or equal to 4 equal to 1 minus probability that x less than 4. You can use this, or you can use this. For this case, it's 1 minus x equal to 0 to 3. That's right, because less than 4. 0, 1, 2, 3. That's right. For this case, greater than 4 or equal to 4, 4 until 16. Okay, you can use this formula. It's easy because you calculate only x equal to 0, equal to 1, equal to 2, equal to 4. That's right. Equal to 2, this you calculate already. That's right. This is equal to 2. You calculate the same. That's right. This is at x equal to 0. That's right. X equal to 0 for this. 18, 0. 0.1 power 0. 1 minus 0.1 power 18 minus 0. Right. For this. And for this, this is 18, sorry. 1. That's right, 0.1 multiplied 1, power 1, 1 minus 0.1, 18 minus 1. That's right. This is p x equal to 1. We need to calculate already p x equal to 2. And this p x equal to 3. You substitute x equal to 3. That's right. And n constant, p constant, p constant, n constant. Only. That's right. Change x. Okay, you get the 8.9%. And the last question, the probability at x between 3 and 7. 3 and 7. That's right. That means x equal to 3 until 6. It's not equal 7. That's right. It's less than 7. Equal to 3 and 7. 3, 4, 5, 6. That's right. 3, 4, 5, 6. This is px equal to 3. Plus px equal to 4. Plus px equal to 5. Plus px equal to 6. That's right. The calculation is the same technique. You substitute x equal to 3. Substitute x equal to 4. Substitute x equal to 5. Substitute x equal to 6. And you get about 26.5%. Okay, this is the technique to calculate. And also for this case, if you calculate by manual or by calculator, it should be difficult if the large data, you can use the Excel. The Excel can help you. You can use the Excel built-in function by binomial distribution, something like this. For this case, you have to enter x. That's right. The first value is x, number of x, and the second one is number of the sample or n. That's right. And p. That's right. Success. And false, we have two, false and true. That's right. For this case, we should false because this is the cumulative. That's right. The probability math function calculate the probability of math function. You have to choose the false value because we calculate the math function probability. That's right. Okay, we will show you x equal to 2. Okay. I will show you in the Excel. Okay, for this is by no. Okay, then for this, the number for this case 2. That's right. Try or 18. Probability is 0.1, and we should found for this case the probability math function. Right. To get 0.284, it's the same. That's right. It's the same calculation. That's right. It's the same calculation. And also you can call for the function. Okay. Let me show you Excel again. We can type directly like this, or you can use the insert like insert function like this. Okay, you can call for this. Right. Okay, you can call for this. Right. We have the function that's like insert function. If you don't know, you can type for binomial. Okay, like this. You can write number is 2, found is 18, property is 0.1, and primitive is found. Should be not cumulative. Okay, the result showing 0.284. It's the same. You can type directly the binomial this, or you can call from the function this, from the function. Okay. I did the technique to calculate the distribution. To calculate the distribution. I show you in Excel and also in the PowerPoint. I show you how to calculate when px equal to 0, equal to 1, equal to 3, equal to 3. You can call for the binomial distribution in Excel. That's right, binomial distribution in Excel. And also you can search by function. That's right, insert by function. Same. And for the next distribution that I will talk to is the negative binomial distribution. That's the negative binomial distribution. For this case, we let like x is the random variable is the same. X is the same. That's right. But we do until success. R is the number of success. That's right. R equal to 1, 2, 3, 4, 5, something like this. P is the probability of success. R is the number of success for this case. You can use, and also you visit the negative binomial distribution. That's right, negative binomial distribution. Okay. You can calculate mu and you can calculate variance by this definition. You calculate based on number of success and probability of success. That's right. Okay. Like for this example, as I we have the website, we have the computer server. For this case, we have 3 servers, but we use only 1, and 2 is spare for when it cannot use the first one. You can use the second and the third for spare. As we have 3 servers, 1 is used and 2 is spare. ก็คือเอาไว้สำรอง When it the first one is failed, you can use the second one, the third one instead of the first one. Okay. The probability of failure in primary computer, as I the probability of failure is 0.0005. This is the probability of fail for the first one. That's right. Okay, for this case, assume that each request represents in independent trial. That's right, independent event, independent outcome. What is the mean number of requests until fail? That's right. Fail. Okay, for this case, we let the X is the number of requests until all 3 servers fail. X means the number of requests that you use the server until it with the fail. That's right, until it fail. Okay, we have 3 servers. That's right. X1, X2, X3. X1 is the number of requests before server 1 fail. X2 is before server 2 fail. X3 before server 3 fail. And then X equal to summary of X1, X2, X3. That's right. X1, X2, X3. And the probability for this case is 0.0005. That's right, 0.005. Okay, for this case, the P equal to 0.005, R equal to 3. That's right, we have 3 requests. And then you can calculate the expected value of X or the mean value. Equal to 3 divided by 0.0005. Okay, you can calculate this R over P. That's right. Equal to 6,000 requests. This is the average 6,000 requests before error, before fail. Right. Okay, for this case, the question, what is the probability that all 3 servers fail with 5 requests? Fail with 5 requests. That means probability that X less than or equal to 3 or to 5. That's like within 5. 1, 2, 3, 4, 5. That's right. 1, 2, 3, 4, 5. But for this case, we have only 3. You have only 3. That's like 3, 4, 3, 5, 6, 3, 4, 5, 6. But it can only within 5. That means 3, 4, 5. Okay. Probability at X less than or equal to 5, equal to X equal to 3, part X equal to 4, part X equal to 5. No 1 and 2. That's right. Because we have 3 at least. The minimum is 3. Okay, for this case, you can calculate by the negative binomial by this formula. That's right, by this formula. X minus 1, R minus 1. That's right, X minus 1, R minus 1. For this case is X equal to 2 minus, that's right, 1, 2, 3. 3 minus 1 and 3 minus 1. It is equal to 1. That's right, equal to 1. Okay. 1 minus P power 3 minus 3. That's right. And P power 3. Okay, this is also equal to 1. You get P power 3. This is the first one. And the second one, this is 4 minus 1, X equal to 4, 3 minus 1, right? 1 minus P power 4 minus 3, P power 3, that's right. This should be 3, 2, that's right, 3, 2, right, for this case. Okay, for this case, and this is the same. And then you can calculate by the technique of factorial. You get about this. The probability is very, very small value within 5. That's right, it's 5. And for this case, you also call for the function in the Excel. You use the NEG, that's right, NEG. This is the same binomial distribution. That's right, binomial distribution. The first one is number of requests. This means number of x. That's right, number of x. And number, this is the threshold of success. The threshold of success. And the last one is the probability. That's right, it's the probability. Okay. Or you can call for the function. That's right, call for the function like this on the Excel. Okay, maybe I will stop the class today. I will continue for the